This is Mars today, a frozen, rusted desert where the air is too thin to breathe and the temperature drops to minus 120 degrees at night. Nothing flows here. Nothing has flowed here for billions of years. And yet, carved into that dead surface, there are riverbeds, dried-up deltas where water once fanned out into standing lakes. Shorelines, flood channels bigger than anything on Earth. This planet is covered in the fingerprints of water that is no longer there. Because 4 billion years ago, Mars may have had a planet-wide ocean, a mile deep, covering a third of the world. And then, somehow, an entire ocean vanished. So here's the question this case file answers. Where did all that water actually go? Because the truth isn't that it dried up. The truth is that this planet was, in a sense, murdered. In this case file, the proof the ocean was real. How a warm, blue, living world became a corpse. The 3 suspects in its disappearance. And the chilling reason the exact same thing could, one day, happen to Earth. Stay to the end, because the last suspect means the water might not be gone at all. It might still be hiding on Mars, right now. Let's open the file. Act 1. The proof. If someone tells you a desert was once an ocean, you're right to be skeptical. So how do we actually know? We don't just guess from orbit. We landed detectives on the surface and had them read the rocks. Start from space. From orbit, Mars is scarred with features that only water carves. Vast branching valley networks, exactly like river systems seen from an airplane on Earth. Teardrop-shaped islands, streamlined by a current that flowed for a very long time. And in the northern hemisphere, a vast, flat, low basin, ringed by what look, unervingly, like coastlines. Then we went down to look. In 2012, the Curiosity rover landed inside Gale Crater and drove up to a spot that, from orbit, looked like an ancient lakebed. What it found in the rock was decisive. Fine layers of mudstone, the kind that only forms as silt settles slowly to the bottom of calm, standing water. Curiosity was parked in a lake that had been dry for over 3 billion years. And it gets more specific than that. The chemistry was right for life. The lake wasn't acid, it wasn't salt poisoned, it was the kind of calm, drinkable water you could have scooped into a glass. Curiosity even found the key ingredients for biology: carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. If you wanted a recipe for a habitable lake, this was it. Then came the closer. In 2021, the Perseverance rover touched down in Jezero Crater, chosen for one reason. From orbit, it contains an almost perfect river delta, the fan of sediment a river drops when it flows into a lake. Standing on the ground, the rover photographed the layered, tilted beds of that delta directly. This wasn't interpretation anymore. It was a photograph of a river mouth on Mars. The minerals sealed it. Across the planet, orbiters and rovers have found clays that only form when rock sits in water for ages, and tiny mineral spheres nicknamed blueberries, made of hematite, which on Earth grows in water. Salt deposits left behind by evaporating lakes. Every independent line of evidence, geology, chemistry, minerals, points to the same verdict. Mars was wet. Not damp. Not occasionally rainy. Blue. And there's a rover story here that still gives geologists chills. Back in 2004, the Opportunity rover rolled out and immediately spotted the ground littered with tiny gray spheres, millimeters wide. They called them blueberries. On Earth, these exact formations grow underground, soaked in mineral-rich water over long periods. Opportunity had landed on a beach of evidence, scattered across the plain, that this place had been drenched. And the water didn't only exist in the ancient past. Look at the steep crater slopes, and you'll find gullies, channels that look startlingly fresh, as if something flowed down them geologically recently. There's still a live debate over how much is water versus dry landslides, but the point stands. Mars and water are not strangers separated by 4 billion years. The relationship never fully ended. Act 2. The world we lost. So let's paint the real picture. because it's more beautiful and more haunting than most people realize. Roughly 3.5 to 4 billion years ago, Mars was not the red planet. It was a blue one. The leading models describe an ocean in the northern lowlands, a body of water scientists have nicknamed Oceanus Borealis. At its greatest, it may have covered 1/3 of the entire planet and held more water, in places, than the Arctic Ocean. Rivers ran into it. Rain, or at least snowmelt, fed it. Clouds likely drifted over a Martian sky that was thicker, warmer, and possibly pale blue. And here is the detail that should stop you cold. This was happening at the exact same time that life was first appearing on Earth. Two neighboring worlds, side by side, both warm, both wet, both wrapped in thick atmospheres. For a stretch of a few 100 million years, Mars may have been just as promising a cradle for life as our own planet was. Which makes what happened next the single greatest tragedy in the solar system. Because one of these two blue worlds went on to fill with forests and oceans, and eventually, us. And the other one died. Same starting line. Wildly different endings. The question is why? What killed Mars? Act 3. The suspects. An entire ocean's worth of water does not simply disappear. It has to go somewhere. And after decades of investigation, we have 3 prime suspects. The first one is the killer everyone knows. But the third one changes everything. Suspect number 1, it escaped into space. To understand this one, you need a single, crucial fact about Mars. Deep in its past, Mars had a global magnetic field, just like Earth's, generated by a churning molten core. That magnetic field was a shield. It wrapped the whole planet and deflected the solar wind, the constant stream of particles blasting off the sun. And then the shield went down. Because Mars is small, only about half the width of Earth, its core cooled and the magnetic field faded away, roughly 4 billion years ago. With the shield gone, the solar wind hit the atmosphere directly and began stripping it away, molecule by molecule, blowing it off into space. As the thick atmosphere thinned, the pressure dropped, and the oceans began to boil away and escape. And this isn't a theory we pieced together from ruins. We caught it in the act. NASA's MAVEN orbiter has spent years measuring the Martian atmosphere, and it can see the solar wind peeling gas off the top of the planet right now. Today, especially during solar storms, Mars is still slowly losing what little atmosphere it has left. We are watching a planet exhale its last breath in extreme slow motion. And the sky itself keeps the receipt. When water escapes to space, the lighter hydrogen leaves more easily than its heavier cousin, deuterium. So if an ocean's worth of water boiled off into space, the water left behind should be unusually rich in that heavy version. Scientists measured it, and that's exactly what they found. Mars's remaining water is loaded with deuterium, a chemical fingerprint proving a vast amount of water genuinely escaped the planet. The atmosphere confessed. Suspect number 2, it froze. Not all the water fled to space. A large amount simply got cold and stayed. Today there is a huge reserve of water ice locked in the Martian polar caps, and buried under the surface, there are sheets of ice as large as entire regions, hidden beneath the dust. Some of Mars's ocean never left. It's still here, frozen solid, waiting. For a long time, those 2 suspects, escape and ice, were the whole story. But they had an alibi problem. When scientists added up all the water that escaped to space, plus all the ice we can find, the numbers didn't match. A huge fraction of Mars's original water was still missing. It was the perfect unsolved case. We knew there'd been an ocean, we could account for some of it, but not nearly all. So where was the rest? Suspect number 3, and this is the twist, the water went into the ground. Not as ice, chemically. In recent years, researchers proposed that an enormous amount of Mars's water was absorbed into the rocks themselves, locked inside the crystal structure of clay minerals as the young, wet crust weathered. The water didn't leave the planet. It became part of the planet, bound into the rock, miles deep, where it may still sit today. So the honest verdict of this case file is not a single killer. It's a conspiracy. Some of Mars's ocean was blasted into space by the solar wind. Some of it froze into ice we can still find. And a great deal of it was swallowed by the crust and hidden in stone. 3 suspects, all guilty, and the ringleader, the one that doomed the whole planet, was the death of a magnetic field. Act 4. Why Earth lived, which leaves the most uncomfortable question of all. Mars and Earth started so similar. So why are you breathing right now on a blue planet, while Mars is a frozen tomb? The answer comes down to one thing, and it's smaller than you think. Literally. Size. Mars is small. A small planet holds less internal heat, and it loses that heat faster, the way a coffee cup goes cold long before a swimming pool does. Mars's core cooled early, its churning stopped, and its magnetic shield switched off. Earth, larger, is still molten and spinning at its heart, and that motion still generates the magnetic field that wraps our planet and holds the solar wind at bay. Our shield is still up. That's the sobering lesson written across the face of Mars. A magnetic field is not a luxury. It is the invisible thing standing between a living world and a dead one. Mars shows us what our own planet would look like without its shield. The water gone, the air gone, the sky gone black and thin. Mars isn't just another world. It's a warning for a billion years in the making. But remember the promise I made at the start. Suspect number 3 means the water may not be gone. Bound in the crust, frozen underground. There could be more water on Mars than we ever imagined, just hidden. And where there is water, even now, there could be a place for something to survive. Deep underground, in the last damp refuges, Martian life, if it ever existed, might still be holding on. And this is not a mystery we're going to leave unsolved. Right now, the Perseverance rover is drilling into that ancient river delta and sealing rock cores into sterile tubes, samples chosen because they're the most likely place on Mars to hold the chemical ghost of ancient life. They're waiting on the surface for a future mission to carry them home to Earth. The answer to whether Mars's water ever became life may already be sitting in a tube on the ground, waiting for a ride. And yes, people ask the obvious dream. Could we just turn it back on? Restart the core, restore the shield, thicken the air, and let it rain on Mars again? Honestly, with anything close to today's technology, no. You can't easily restart a planet's frozen heart, and even bold ideas, like parking an artificial magnetic shield between Mars and the Sun, are firmly in the realm of century-scale dreams. Mars broke on a timescale, and in a way, that dwarfs us. 2 worlds started at the same line. One kept its shield and filled with life. The other lost it and became a monument to everything that can go wrong. Mars didn't just lose an ocean. It lost the chance to be Earth. So here's tonight's question for the comments, and I really want your answer. If we had the power to give Mars back its magnetic field, warm it up, and pour the oceans back in, to bring a dead world back to life, should we do it? Or does Mars belong to Mars? Tell me below. Subscribe for the next case file. And keep looking up.